This lesson is about foundations. There are multiple types of foundations. We have crawl spaces, we have basements, we have stone foundations, we have concrete walls. There's a lot of different variables going on. The basement foundation is, in my mind, the basement inspection, in my mind, is one of the most important inspections that we do. Everything leads to the basement. I can tell if I have a basement problem by separation of my rafters in the attic. I might have a basement problem because I don't have gutters that go out long enough. I can look at the top of the foundation when I'm walking around the house, looking at cracks in the foundation wall. So you're really doing a basement inspection or foundation inspection as you're looking at the rest of the house. When you get into that basement, you need to make sure that all the support columns are in good condition. You have a main beam you have to look at. There's just so many important things that happen in the basement. So let's get on with this lesson.
Now I'm going to show you how to perform an inspection of a basement. This is a critical piece because this is going to consist of a structural evaluation of the home. I'm going to show you how to perform the inspection of the basement, and then we're going to cross-reference it with the checklist so you don't become negligent. Now, there are multiple elements of a basement inspection. First, we're going to be looking at the stair system, the railing system. Then we're going to move on to the sill plate and rim plate. We're going to be looking at the wall along with the window. We're going to look at the joint between the wall and the floor, which typically has a French drain. Thereafter, the next element, we're going to be looking at the joist and the floor structure, the main beam along with the main post, and then we're going to be ending with the sump pump. So let's get started. As I was walking down the stairs, one of the things that we can just notice, just because we end up walking up and down the stairs, are the stairs level? Do we feel like we're falling forward? And I didn't feel that at all. Secondly, we can see that it structurally has an integrity to it. We want to see a railing and make sure that is sturdy at the same time. Now, the next item, or the next element we're going to be looking at is the sill plate and rim plate. As you can see, it's going to be difficult. So in this situation, I do move the insulation a little bit all the way around the basement. So up here, we're going to be looking at the sill, all right? And then we're going to be looking at that rim plate. And the reason why we're looking at these particular locations is to make sure there's no deterioration or water infiltration. And then we're going to look at that particular item and that one element all the way around the basement. The next item, as I walked around the basement, you're going to see that we have a vertical crack. Now, vertical cracks doesn't always mean there's a structural problem. Vertical cracks can form because of shrinkage when the concrete was forming, or maybe when they were backfilling, there was too much pressure when they were putting the dirt back in there, and they didn't give enough time for the concrete to cure. So looking at this, you can see that this crack has opened up over the patch. Also, you can see where they painted. So there's still some movement in this vertical crack. What we end up doing when it comes to vertical cracks is we're going to feel that crack. And what I'm not feeling is any displacement. And as we go down, you can see that, all right, this has been patched up a little bit and it's been painted, so it's a little wider up there than down here. Now, another technique to determine if the footer has been broken is by placing your hand up here on the top of the crack. If that section is flat and there's no displacement, that means your footer is intact. If your footer broke, there would be a displacement up on the top of the concrete. So, how would we identify this in the report? This would be a monitor, all right? Because there is no structural concern about this, but we do want to monitor if this crack is getting larger, okay? Now, the next element we're going to look at, and for each of these, again, you're going to continuously walk around the basement for each of these single elements. It's almost like eating an elephant. You're not going to eat the whole thing. You're going to eat small pieces of that elephant, all right? So now we're going to look at the French drain. We can see that looks like it was a homemade French drain all the way through, so we want to make sure all the debris and everything is clean through. And then we're going to look at the concrete floor. And here, it looks like there was some repairs. Now you can see this crack, and again, it's all about displacement. I'm not feeling any displacement. But can you see how this crack is reforming over the repair? That means there's still some movement. Once again, I'm not feeling, we're going to feel it all the way through. We're going to keep on looking, but I'm not feeling any displacement through it. But because of this crack forming, again, we're going to monitor this situation. I'm not saying there's any structural defects. I'm saying that we need to monitor this. And what we have is, we have a crack here, and then it's continuing here. But nothing has given us an indication of a structural defect. One thing I want to point out is, when we were inspecting the wall and walking all the way through, we wanted to look at the window. So let's take a look here. This looks like the original basement window was removed. They put in these glass blocks with a small window to create some ventilation. Once again, we're not looking at the craftsmanship, we're looking at the safety, operation, and condition. So overall, I don't see any water leaks. I see that the blocks are securely in here. I see the operation of the window can be operated. There's no defects there. So once we identify this window, this is going to become our standard. So now we're going to look at this and compare them to all the windows in the basement. So once we perform that, we're going to be looking at the joists and the flooring. The next element we're going to look at is the actual decking of the floor and the joists. So what you're going to do for the entire basement is you're going to walk inside this channel, and you're going to be looking at the joists and you're going to be looking at the decking, specifically to see if there's any deterioration, is there any wood destroying insect damage. Also, by looking at this particular section, you're going to review electrical connections, plumbing connections, heating and cooling connections. So that's where you actually help yourself re-inspect those sections so you don't become negligent, because it is going to be associated with the decking and the joists. So as you walk up and down each of these sections, all right, you're going to be looking at the joists. And then once you walk up and down these sections, you're going to walk to see this particular face of the joists and the decking. And then you're going to turn around and look at this section. Because the basement is so large and we're going to be breaking it up into these small elements, there's so much information in there that you can be inspecting. We want to take our time. Now, one of the next elements we have is our main beam and our supporting joists. So here's our main beam. It is actually built up with wood. We can see we have a pocket in the foundation. That is the supporting structure for our main beam, which carries the load to the footer. Now, we're going to be looking at this main beam from afar, and one, we want to see, is there any bow in this main beam, which I'm not seeing any bow. We want to make sure that the joists are overlapping over the main beam. As we move forward, we can see that we have a supporting beam. Here, we do have a defect because there are no fasteners that are being attached to the plate, and then typically there's a nail which then would be crossed over here, so there is no movement. Next, we're going to be looking at the overall condition. We're going to be coming down here, looking at the plate. Again, there should be some sort of fastener that's attaching this, because just in case we don't have any movement. And then we're going to be looking, just because it's metal and we're in a back basement, because of humidity, is there any surface rust? Which I don't see any. So that actually looks fantastic. And then what we're going to do is we're going to continuing looking at this main beam in small sections, and then we're going to follow it and all the way down to the other side. Now the last element we're going to be looking at is the sump pump. So what we're going to do is we're going to get started looking at the sump pump. And again, you always have to make sure that you're in a safe environment. So here we don't have actually any water in the sump pump. So I feel confident that I can actually reach my hand in there and touch the wand and move it. I want to see if I can actually operate this sump pump. If there is no water, we just want to see if it's going to kick on or not. So let's do that. The pump did not kick on. So let's understand why the pump didn't kick on. So we're going to be looking at the electrical cords. We're going to be coming over in this direction so we see that it's connected. And we know that it's plugged in here, and we know that the breaker is in the on position. So at this point, we're going to say that the sump pump did not operate at the time of the inspection. Recommend to contact a qualified contractor. So let's continue inspecting the sump pump region. Now, we're going to notice that we have PVC pipe. We actually have a check valve, so water is going to flow up. So we don't have water. Once the pump turns off, water's not going to come all the way back down. It's going to stop in this location. I would like to see some sort of hanger or structural member so you don't get so much movement. As the pipe comes up, you're going to see that they do have one up here, which is not really doing much. And then it's proceeding to the outside. And when we perform the basement inspection, we're going to look at that discharge location out of the rim plate to make sure there's no deterioration at that point. Now, one of the items that you want to take note of is I'm going to identify how or what the outlet is. Is it a GFI or if it's a regular outlet? In my opinion, I can have 20 inspectors here, and 10 of them are going to tell me why it should be a GFI, and the other 10 are going to tell me why it should be a regular outlet. Now, for our purposes, we just want to identify to the client what it is. All right? And this is how we're going to perform a sump pump inspection. Now that we completed the sump pump inspection, we're going to go back to our basement checklist. And we're going to go through each of the sections in the basement checklist. We're going to look at the questions and re-perform this inspection. The reason why we want to do that is to make sure we covered everything within our SOP, our standard operating practices. And this is how we don't become negligent and miss anything. So for example, we're going to be looking at the basement walls. We're going to be looking at the main beams. We're going to be looking at the windows. We're going to be looking at the floor. And we want to go through and perform that checklist evaluation. This is critical because everybody is concerned about the structural foundation of the home. And by performing that element inspection and then going back to your checklist, it's so critical that you don't become negligent. And that's how we perform a complete basement inspection.
Foundations come in many shapes and sizes. The one important characteristic that all foundations have in common is they support the entire weight, static and dynamic loads, of the home and its occupants. Therefore, every item in the house is transferred to the supporting structures of the house, which is directly transferred through the foundation walls, directly to the foundation footing. Footings are located underneath of the foundation wall, which sits directly on what should be undisturbed soil. The footings carry both the dead load, the static load, and live loads, dynamic, of the house and transfer these loads onto the ground below. During this lesson, you will describe foundations in two ways: types and styles. Review the chart on this screen for the types and various styles of foundations. Standards of practice. The inspector shall inspect the basement, the foundation, the crawl space, the visible structural components, any present condition or indications of active water penetration, probing a representative sample of structural components where deteriorations is believed to be present, or anywhere clear indications of deterioration is present, and report any general indications of foundation movement observed, such as, but not limited to, sheetrock cracks, brick cracks, out-of-square door frames, or floor slopes. The inspector is not required to enter any crawl space that is not readily accessible or where entry could cause damage or pose a hazard to the inspector in his or her opinion. Move stored items or debris. Operate sump pumps with inaccessible floats. Identify size, spacing, span, location, or adequacy of foundation bolting, bracing, joists, or support systems. Provide any engineering or architectural service. Report on the adequacy of any structural system or component. As a home inspector, you will come across many types of foundation walls, although the following are most common: stone and or stone rubble foundations, brick foundations, poured concrete foundations, cinder block, pressure-treated wood foundations, and insulated foam foundations. Stone and or stone rubble foundations are usually thick, ranging from 24 inches up to 48 inches. The stones were usually removed from the farmer's field to supply the material to construct the foundations. The biggest drawback to these types of foundations was the mortar. The mortar used was sand, and over time deteriorated and allowed infiltration of water. Brick foundation. This type of foundation was more likely to be used in built-up areas such as cities. Compared to bricks fabricated today, these were considered soft bricks. These types of bricks would absorb moisture from the ground, allowing over time the foundation to leak and or compromising the brick's structural integrity. As a result of the bricks absorbing moisture, the water would wick up to the wood joists. As a home inspector, is this an area of concern? Yes. Be sure to look at each joist and use a screwdriver to gently check for wood rot. In some cases, rotting joists will collapse where the wood joist sits on the top of the brick foundation. Poured, in-place concrete foundations. The most common type of foundation today is the poured in-place concrete foundation. Once the forms are placed, it is simply a matter of pouring the concrete into the voids of the forms and allowing the foundation to set up from a minimum of 24 hours before the floor is installed. There are two areas of concern that can compromise a foundation after being poured: backfill and weather conditions. Backfilling in this type of foundation must be done with care, especially if there is no bracing or lateral support. Too much pressure from the backfill and the wall will crack or, in extreme cases, collapse. If an outside foundation crack is left for extended periods of time without being repaired prior to backfill, water that gets trapped inside the crack will freeze and expand, thereby increasing the size of the crack and allowing more water to penetrate it, and the cycle will repeat. Therefore, over time the process will repeat, eventually causing a structural failure. Concrete or cinder block foundations. Similar to brick foundation construction, blocks were laid against one another with mortar in between them, and then built layers of courses or rows to create the foundation. concrete blocks are made approximately 8 inches in height, 16 inches in length, and either 8 inches or 10 inches in width. These types of foundations had to be completely covered with cement coating on the exterior and coated with a heavy, brashable tar to prevent the ground and surface water from entering the block foundation. The biggest problem with this type of foundation is that if a leak occurred on the exterior, it could appear in a completely different location on the interior. As a home inspector, you will find this more widely used for additions, and/or as do-it-yourselfers will use this system as well as most handyman who can mortar the blocks into place. Here are some examples of these foundations. Pressure-treated wood foundation. The pressure-treated wood foundation, PWF system, is an engineered construction system and has been tested both in laboratories and underneath literally thousands of homes, as well as in agricultural and commercial applications. The PWF walls are built similar to the wood-framed walls in a normal house. However, there is one major difference. The plywood and all of the other lumber components are pressure-treated with wood preservatives which chemically bond deep into the wood. This treatment protects the wood in the foundation from fungal growth, insect infestations, wood rot, and other causes of decay permanently. Insulated concrete forms, or ICF. Pre-insulated, or ICFs, have subtle differences in the manufacturing process as they are similar in design. Most of these types of foundations use polystyrene as the actual forms the concrete is poured into. Unlike the typical poured concrete foundation, where the wooden or metal forms are moved after the concrete has set up, the ICF's forms stay in place after concrete is set and left behind as a form of insulation. Although for the sections of foundation that is considered above grade, parging of the polystyrene block is required. Foundation styles. There are several styles of foundations: full, crawl space, slab on grade, and pier foundations. Full foundation. A full foundation basement has either poured concrete walls or block and mortar walls on a poured concrete slab floor. The load-bearing walls of a house are supported by both the foundation's perimeter walls and structural crossbeams and/or post-in beams. A crawl space is a type of foundation that elevates the house a minimum of 18 inches from the ground. Crawl space foundations are normally waterproof with a vapor barrier along the bottom of the ground. Crawl spaces normally contain the plumbing, electrical, and heating and cooling system ductwork. As a home inspector, ventilation through the crawl space is a very important characteristic. The crawl space should have a minimum of 150 square inches of ventilation per 100 square feet. A slab-on-grade foundation is a concrete floor installed on undisturbed soil below the topsoil. This is done similar to a basement floor. The topsoil is removed from the ground, forms are installed, and a concrete pad or floor is poured. The concrete pad is reinforced with metal. The metal reinforcing can be either in the form of half-inch or 3/4-inch bars tied together at right angles, or heavy wire mesh can be laid in place prior to pouring the concrete. In some slab foundations, insulation is used under the floor to prevent heat loss and reduce energy costs, in addition to reducing the depth of frost penetration. Anchor bolts are installed in the concrete along the outside perimeter of the pad to secure the lower plate of the wall. This system of building a foundation is normally used for self-supporting, standalone buildings that are usually 1 story in height, such as a house, a freestanding garage, or even a large shed. This slab on grade is not below the frost line. Another common term used to describe this type of foundation is a floating slab or an Alaskan slab. A pier foundation is a long, cylindrical concrete tube that extends below the 4-foot frost line. Most piers are constructed of either poured concrete or concrete block bonded together with mortar, or in some cases, wood piers. These wood piers should be either pressure-treated, womanized, or natural cedar. At the top of the pier, there should be a metal bracket to accommodate a beam. This U-shaped bracket will have a stem protruding from the base, which is set into the top of the pier. As an inspector, you will want to crawl under the house to check on these piers to see if they are level, plumb, and if they are in good condition. You will also determine if they are secured to the beams. The purpose of the foundation is to transfer the entire load of the house to the bottom of the footer to the soil. When inspecting the foundation of the house, there are some key exterior indications to take notice of before inspecting the basement: the roof peak and/or ridge line. Distortions or sags in the ridge line can be a sign of foundation problems. Racking. Are the exterior walls 90 degrees to the foundation, or are they on an angle from the foundation? Twisted or distorted siding. This can be caused from improper settling of the footing and/or foundation walls. In masonry chimneys, if the chimney is not plumb, you'll need to consider if the chimney has a separate foundation or is part of the house's foundation. Basement indications for movement. The diagrams on the next slides are only a guideline as to why some cracks occur. Never put yourself in the position of stating the reason for these cracks. Always refer your client to an engineer who specializes in residential foundation problems. Foundation cracks can be scary for the inspector. You shouldn't try to determine whether the crack is a structural defect or not. If you are unsure, say so. Don't try to pretend you know it all. That is what will land you in court. Cracks that do not pierce the wall and do not show displacement in any direction are not to be considered structural. Cracks that are not considered to be active are no larger than 1/4 inch in width and show no displacement is not to be considered serious. Even if water is leaching through the crack, the repair is normally inexpensive. Cracks that are in excess of 3/8 of an inch or larger should be considered serious and investigated further, as these could be or become structural, especially if there are signs of displacement. And active cracks, such as cracks that have sharp edges and have broken through new paint or newly repaired mortar joints, are cracks that should be addressed. These indicate movement and could lead to a problem. The following images below are examples of cracks that could be seen during an inspection. Worst type of crack: horizontal. Vertical cracks are normally due to the settling of the house and foundation. This type of crack is not considered a structural concern if it does not involve the footer. Horizontal cracks are considered a structural concern. Horizontal cracks are considered the most dangerous. If a horizontal crack is displaced and the entire wall is not plumb, it should be reported as a defect. To determine if a wall is plumb, take a 4-foot level and lay it against the wall going over the crack. Pin the bottom of the level to the bottom of the wall below the crack. If the top of the level is not touching the wall, then the amount of distance between the level and the wall is how much the bottom of the wall has moved. Always report this as a defect. Moisture in the basement. Water will always take the path of least resistance, unless under pressure. Normal water buildup in the drainage lines, or weepers, even in the spring when the water table usually rises, will seep into the basement. These are some common symptoms or signs of water infiltration. Water trickling down the interior foundation wall. Water pooled on the basement floor. The bottom course of concrete block walls are darker due to water saturation. Damp, humid air, or musty smell. Evidence of condensation on cooler walls and concrete floor during the summer months. Evidence of mold and mildew. Deterioration of carpet or rotting wood. Deterioration of wood heaters, joists, beams, sill plates, and rusty metal columns. Staining of wall covering and blistering drywall or sheetrock. Efflorescence or spalling on concrete or masonry. Moisture problems in existing basements are very common too, but these problems often are not understood or repaired. As a home inspector, you should know there are 3 sources of moisture. 1. Liquid water from rain, or groundwater, such as underground streams. Rainfall, amounting to 1 inch per hour, is approximately 1,250 gallons of water on the roof of a 2,000 square foot house. Depending on the season, below-grade water table can also rise due to flooding or season conditions, such as a spring runoff. 2. Interior moisture sources such as humidifiers, unvented clothes dryers, bathrooms, and cooking, as well as the moisture in concrete after construction. And 3. Exterior humid air that enters the basement through penetrations and condenses on the cooler surfaces. As water lies against the concrete wall or block, a force is developed called hydrostatic pressure. This force or pressure pushes water and vapor through the concrete. Consequently, salt and lime are pushed through the concrete and deposited on the opposite side of the concrete foundation. This is called efflorescence, which is a salt and lime stain forming on any masonry product where water has pushed through. Efflorescence appears as a white or tan powder, which develops a surface thickness of 0.2 inches. As a home inspector, if you notice efflorescence the day of the inspection, this is or was a sign of water accumulation along the foundation wall. This is the first signs of water infiltration. A sump pump is a pump used to remove water that has accumulated in a water sump basin, commonly found in the basement of homes. The water may enter via the perimeter drains of a basement waterproofing system funneling into the basin, or because of rain or natural groundwater if the basement is below the water table level. Sump pumps are used where basement flooding happens regularly and to remedy dampness where the water table is above the foundation of a home. Sump pumps send water away from a house to any place where it is no longer problematic, such as a municipal storm drain or a dry well. Inspecting a sump pump. There are a few steps to inspecting the operation of a sump pump. 1. Lift the wand or raise the float to see if the pump operates. 2. If there is water in the well, lift the wand or raise the float to see if the water drops. Once you release the wand or float, listen and observe if water trickles back into the well. A controversial issue among industry professionals is, do you write a defect if the sump is not connected to a GFCI outlet? There is an argument for either situation. Some say the pump needs to be connected because of an electrical outlet and water is in close proximity. Others say if the GFCI is triggered, the pump won't work and the basement might fill up with water. I suggest you note if the pump has a GFCI or if it doesn't have a GFCI and not make a concern out of it. If you make a concern out of it, then in effect, you are offering engineering advice. Here are the inspection sheets for the foundation. Take a few minutes to review the next slides.
Okay, that was the basement foundation lesson. And the most important thing we have to pay attention to is this takes a lot of attention. No matter what kind of foundation you have, whether it's a poured concrete foundation, whether it's on piers or a crawl space, being very thorough when we're doing the inspection. For example, when you're in a basement, you have those walls, looking for the cracks, looking for the moisture penetration, looking at the sill plates, looking for the mold. All these things are extremely important. The rest of the house is built on top of this foundation, and you have to be very thorough with it. So good luck on the quiz.